Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Next problem or next numerical. And this problem has also chosen from the same book which we are following for many weeks. That is Modern Physics by Kenneth S. Crane. Dear students, from this problem, we are going to start a new topic which we have not yet touched. Since we have started this book, that is Modern Physics by Kenneth S. Crane. Okay, that is to say, this is a potential well. Okay, we are dealing with potential well in this problem, infinite potential well. Okay, and as per our policy or strategy, whenever some new term or new topic or new concept is initiated, we try to develop some base or foundation for that basic for that newly introduced term or concept or topic. Okay, so this topic is also being introduced for the first time, so definitely we will develop some base or foundation in order to have some basic knowledge about the background of that concept. Okay, of this topic, several problems are yet to come in our upcoming videos. Okay, so dear students, for the time being, I have chosen only one tool to introduce this newly introduced term or concept or topic, that is the infinite potential well. But in our near future, in our upcoming video lectures in near future, we will try to introduce various versions of this topic or term. Okay, anyhow, because this is quite a beginning of this topic, so for the time being, I have chosen only one snapshot from a book regarding this newly introduced topic. But in our upcoming future videos or problems, we will definitely include several versions of this tool. That is to say, a tool in which energy levels and potential well and infinite potential well etc. is being introduced. Okay, so anyhow, we come to our problem statement first. This is actually very short problem. Its solution is not lengthy. Okay, quite simple and short problem. Dear students, as it is also a part of our policy or strategy that we move from simpler to harder problems. Okay, So perhaps this is the simplest problem of this topic. That is why this problem has been chosen first. Then gradually harder problems in this topic will be dealt with. Okay. Dear students, statement of this problem is the lowest energy of a particle in an infinite or infinite one-dimensional well is 4.4 electron volt. If the width of the well is doubled, what is its lowest energy? Okay. So dear students, here one energy is given and other energy is to be determined or to be known. Okay. All remaining work will be carried out with the help of the definition which deals with this newly introduced topic, that is potential well or infinite potential well or energy levels, etc. Okay. So in this problem only one tool has been introduced. Okay. But as I have already described that in our next problems various versions of this tool will be chosen from various books and included in our video. Okay. Presently only one snapshot is available regarding this problem. Okay. So this is, now we come towards the helping tools, and for this problem there is only one helping tool. Okay. So we come to this helping tool. This helping tool says that energy levels for a particle in a box denoted by En, where N is written as a subscript of N, where N is written as a subscript of E, energy E, is equal to Pn square divided by 2m, where P is the magnitude of momentum. Okay. N is a quantum number. M is particle's mass. Okay. Dear students, this expression is in the second time expressed in a different manner. Okay. So, that is to say, next equivalent expression is a new form of this definition. This becomes equal to n square h square divided by 8m capital L square. Okay. Where h is Planck's constant, which we have dealt so many times in our previous videos. Okay. And n is a quantum number. Okay. It varies from 1 to and so 1 to 3 to and so on. Okay. Where capital L is width of box. In this problem, it is described that value of E1 is given because the lowest energy. Dear students, the lowest means the lowest indicates n equal to 1. Okay, and we have also to find lowest energy in case when L is doubled. Okay, width of potential value is doubled. Then we have to find that energy of the that lowest energy. Okay, that is, then again n is once again equal to 1, because that is also lowest energy. Okay, so we have discussed that energy levels for a particle in a box En has become equal to n square h square over 8 m l capital L square, where capital L is the width of box and h is Planck's constant, n is quantum number. This expression is once again described in a slightly different mode as being equivalent to n square pi square h cut square over 2ml square. Okay, why 8 has been converted into 2? Dear students, actually this is not Planck's constant h, this is Planck's constant divided by 2 pi. Okay, when we divide Planck's constant h by 2 pi, then it is called h cut. Okay, so in the first expression, n square h square divided by 8 m capital L square, but this has become alternatively equal to n square pi square h cut square over 2m L square. Dear students, actually because h cut is equal to h over 2 pi. Okay, h cut is equal to h over 2 pi, and when we will take h square, h cut square, then it will mean h square over 2 pi whole square, meaning h square over 4 pi square. So dear students, actually this expression is due to that reason, because this is n square pi square h cut square. If we replace h cut square by h square over 2 pi whole square, that is h square over 4 pi square, then this pi square will be cancelled with pi square, and 4 and 8, in place of 8 we will get 2. Okay, it should be made clear. It is quite simple step. Nothing has been introduced which is beyond our understanding. Okay, the whole thing which is material or which is meaningful in this statement is that in this definition a new symbol, that is h cut, has been introduced, while h cut is equal to h divided by 2 pi. According to this arrangement, n square h square over 8 m capital L square has become equal to n square pi square h cut square over 2m capital L square. I once again describe the step which, if we take, we will revert to previous step. Okay, what we will do, we will replace h cut square by h square over 4 pi square, because h cut is equal to h over 2 pi. Therefore h cut square is equal to h square over 2 pi whole square, that is h square over 4 pi square. Okay, if we convert h cut square into simply h square, then it will become h square over 4 pi square. That is why this pi square is written along with this, so that that pi square will be cancelled with this pi square, and 4 will convert 8 into 2. Okay, so I think it is clear. Even if it is not clear, it will be made quite clear in next problems, next videos which deal with this concept. Okay, so En is equal to Pn square over 2m, where Pn is the magnitude of momentum, m is the particle's mass. This has become equal to n square h square over 8m capital L square, where capital L is width of box, h is Planck's constant, and n is quantum number. This alternatively becomes equal to n square pi square. Pi, we know that pi is equal to 22 by 7, and its decimal representation is non-terminating and non-repeating. However, we usually restrict value of pi, that is 22 by 7, up to 2 decimal places, that is 3.14. But in reality, after 1/4 it goes endlessly. Despite involvement of most modern and most fast computer of this age, okay, it goes endlessly. It is non-terminating and non-repeating. This is a very special number. Perhaps it is called transcendent number. Okay, anyhow, I am not sure at this point. So En has become equal to n square h square over 8m capital L square, and this has become alternatively equal to n square pi square h cut square divided by 2m capital L square, where n is quantum number, n is equal to 1, 2, 3 and so on. Now we come to solution. We know that En is equal to n square h square over 8m capital L square, where n is equal to 1, 2, 3. Okay, where m is particle's mass, h is Planck's constant, L is width of box, and n is quantum number. Okay, dear students, actually the tool which we have introduced, we have derived this expression from that tool. Okay, the only difference is that in that tool such things have been described with arrows, and those arrows are not quite straight, they are slightly circular shaped arrows. Okay, so in other words, we have reshaped our tool in this mode, in this form. Okay, En is equal to n square h square over 8m capital L square, where n is equal to 1, 2, 3, where m is particle's mass, h is Planck's constant, L is width of box, and n is quantum number. What we have done? We have done nothing. We have just reshaped definition described in tool number 1. Okay. Okay. It is given that because lowest energy is under consideration, lowest energy means quantum number is 1. In place of n, we will take 1. Okay. It is given that E1 is equal to, in place of n square, we will use 1 square, and we know that 1 square is also 1, 1 cube is also 1, 1's fourth power is also 1, 1's eighth power is also 1. Okay, so E1 becomes equal to h square over 8m capital L square, and this is equal to 4.4 electron volt. This is given in the statement. Okay, this value 4.4 electron volt is given in the statement. So we have not done anything. We have only made an arrangement in which we have used n equal to 1 and we have put this value equal to 4.4 electron volt, which is given in this statement. Okay, now we suppose that let E1 star in place of En, in place of E1, this is E1, but now we are going to find lowest energy where width of potential well has been doubled. Okay, so let E1 star be the lowest energy of the particle with width 2L. Okay, previously its width was L, but now as per condition described in the statement, this L has become doubled. That is, in place of L we will use 2L. Okay, let E1 star be the lowest energy of the particle with width 2L of potential well, then E1 star is equal to h square over 8m into 2L whole square. Okay, because when L has been replaced by 2L and as per formula or definition or expression L is in square modes, then 2L whole will also be in square mode. So E1 star becomes equal to h square over 32 ml square. Okay, because square of 2 will be 4 and 4 into 8 will be 32. Okay, so E1 star has become equal to h square over 32 ml square. We can write this expression as being equal to h square over 8 ml square into 1 by 4. Okay, we have separated the multiplying factor 4 on the right because left part of this expression is exactly equal as in E1. So its benefit will be that in place of this first expression on left we may use the value 4.4 electron volt. Okay, this is equal to E1 into 1.4 because first portion is equal to E1. Okay, so here we have used E1 into 1 by 4 and in the next step in place of E1 we have used its equivalent value in terms of electron volt, that is 4.4 electron volt. Okay, so this has become equal to 4.4 electron volt into 1 by 4. Okay, so when we will divide 4.4 by 4, then we will get 1.1. So E1 star has become equal to 1.1 electron volt. This is our required solution. That is, the lowest energy was given 4.4 electron volt and only alteration was given that width of potential well is doubled. So if width is doubled, then energy becomes 1/4 because width denoted by capital L comes in square form. So from here we can make a conclusion that if suppose width is made triple, then E1 dash will become ninth part of this. If width is increased 4 times, then E1 star will become 16th part of this. Okay, and so on. This is quite a additional discussion. We do not need it for the time being. Okay, anyhow, this is the solution of our problem. Till next problem, Allah Hafiz.